Welcome to my YouTube channel Raise a Cat, and today we will be seeing graphs on different types of processes in thermodynamics. Okay, so moving further in thermodynamics, we will see different types of graphs or different processes. So first process is isobaric process. Okay, second is isochoric process. Third is isothermal process. Okay, so third is isothermal process. And fourth is adiabatic process. Okay, so these are the four processes which we will see in this isobaric process, isothermal, isochoric and adiabatic process. Okay, so let's see in detail the graphs of this isobaric process. Okay, so isobaric process. Okay, so in isobaric process pressure is constant. Okay, so the graphs will be, so in the isobaric process the pressure was constant. Okay, so we have equation, general equation, which is PV is equals to nRT. Okay, so if pressure is constant, so V is directly proportional to temperature. Okay, so volume is directly proportional to temperature in case of isobaric process. Okay, so the graph of this volume versus temperature, volume in y-axis and temperature in x-axis, okay, will be a straight line passing through origin. Y is equals to mx kind, okay, or V is equals to lambda times T. Okay, so this will be the type of graph for this isobaric process, VT graph. Okay, and TV graph also same, TV graph also passing through origin, same thing. Okay, so T is equals to lambda dash V. Okay, and pressure versus temperature, this pressure versus temperature graph will be a straight line because pressure is constant. Okay, so PT graph will be a straight line. Okay, and this PV graph will also be a straight line because the pressure is constant. So these are the type of graphs, four graphs, which will be there in isobaric process. Okay, since pressure is constant, so PV and PT graphs are a straight line, and TV and VT graphs are passing through the origin. Okay, so this was for the isobaric process. Okay, so let's see the next process, which is isochoric process. Okay, so isochoric process. Okay, so in the isochoric process the volume is constant, V is constant. Okay, so suppose that this is the reaction which is there, so here the volume will be constant. Okay, so in this the general equation is PV is equals to nRT. Okay, so P is directly proportional to temperature. Okay, because all other are constant, volume is constant, Vn is constant, and R is constant. So P is directly proportional to T. Okay. So in this the graph will be like P versus T. Graph will be a straight line. Okay. P is equals to lambda T. Okay. So this will be the graph for the pressure versus temperature, and temperature versus pressure also same thing. TP graph also straight line. T is equals to lambda dash P. Okay, so this will be also kind of y is equals to mx. Y is equals to mx kind of graph. Okay, and this V versus T graph will be a straight line. Okay, since the volume is constant. Okay, and this volume versus pressure will also be a straight line. Okay, since the volume is constant, so Vp and Vt graph will be a straight line, and Pt and Tp graph will be a straight line but passing through the origin. Y is equals to mx kind. Okay, so this was for the isochoric process. So let's see the next process, which is isothermal process. So the third process is isothermal process. Okay, so in the isothermal process, whenever a reaction is happening, suppose that this is the reaction vessel and two reactants A and B are there. So in this always the temperature will remain constant. Okay, so we know the relation PV is equals to nRT. Okay, so in this the temperature is constant, so PV is equals to constant or C. So P is directly proportional to 1 by volume. Okay, so this is the relation, that P is equals to 1 by V. Okay, so this PV graph, P versus V graph will be a like a Y is equals to 1 by X kind. So here the graph was y is equals to mx. Here the graph will be kind of y is equals to m by x. Okay, so 1 by x graph is a curve. Okay, so P versus V graph will be like this. Okay, and this V versus P graph will also be a kind of y is equals to 1 by x kind. Okay, Vp and PV graph will be like this. Okay, and this T versus P graph will be a straight line with constant slope, and this T versus V graph will also be a straight line with a constant slope. Okay, with a zero slope. M is equals to 0. Okay, so the slope in this both will be 0. Okay, and these are for the PV and Vp graph. So for the isothermal process, this was the general equation, and this we found that P is directly proportional to 1 by V, and these are the graphs which we can plot. Okay, so this was for the isothermal process. Let's see the next process, which is adiabatic process. Okay, so next is adiabatic process. Okay, so in adiabatic process, the heat supply to system or heat removal from the system. Heat removal from the system or heat supply is 0, or the Q is 0. Okay, value of Q is 0. So in the case of this adiabatic process, Q was 0, and the equation is P V की power n is equals to constant. Okay, so this is the general equation for the adiabatic process, PV to the power of n is equals to constant. N can be anything. If n is 1, the value will be PV is equals to constant, which will be a isothermal process. If n is 2, it will be a PV to the power 2 is equals to constant. Okay, so like this the equations will be there. So the graph of P versus V will be P versus V graph. Okay, so P is directly proportional to 1 by V की power n. Okay, so graph of first graph will be, for 1 will be like this, and next will be 1 by x square. Okay, so 1 by x square graph will also be like this only. But what will happen? Suppose that this is x square. Okay, so this is x square. Okay, suppose that x is from 0 to 1. So x square value will decrease from 0 to 1. Okay, so 1 by x square value will increase from 0 to 1. Okay, so 1 by x square value will increase from 0 to 1. Okay, so 1 by x square and 1 by x cube graph will be above it. Okay, and 1 by x की power 4 graph will be above it. So like this. So 1 by x to the power of 4, 1 by x to the power of 3, 1 by x square, and after 1, 0 to 1, x square will increase, so 1 by x square will decrease. So this concept is used for making the graphs of PV to the power of n is equals to constant. So 1 by x, 1 by x square, 1 by x cube, and 1 by x to the power of 4. So P versus V graph will be like this. Okay, so let's see the V versus P graph. V versus P graph for adiabatic process. Okay, so we know that V to the power of n is equals to constant. Okay, or P to the power of 1 by n versus V is equals to constant. Okay, so V versus P graph. So V is directly proportional to 1 upon P to the power of 1 by n. Okay, so for n is equals to 1, it is same as y is equals to 1 by x graph this. But for this P when the n is 2, so the value will be 0.2, 0.5. Okay, so when n is equals to 2, so V is directly proportional to 1 upon P to the power of 0.5. So the graph will be opposite to the which was for the P to versus V graph. Okay, so the 1 by x square graph will come here. Okay, so V is directly proportional to 1 by P to the power of 0.5. Okay, so this is for V is directly proportional to 1 by P. Okay, so and this third graph will be for V is directly proportional to 1 upon P to the power of 0.33. Okay, when n is equals to 3. So like this the graphs will be there, which is opposite to the graphs of P versus V. So the opposite trend will be there for this. Okay, so in the adiabatic process, let's see the graphs. As we know that the equation is PV to the power of n is equals to constant, so the Q is 0. Okay, so in this the temperature versus this pressure. So the temperature in the adiabatic process will keep on decreasing as the process will go on, because we know that the internal energy is NCV dt, but the energy supply for this is 0. energy supply equal to 0, so that internal energy U internal will decrease. Okay, so temperature will decrease. So these graphs we can make if the trajectory of this pressure, we know that what are the different types of pressure we know, and from that we have to calculate this temperature, so we can predict that the temperature will decrease with respect to time, because the internal energy is decreasing, so the temperature will also decrease. Okay, because the internal energy is decreasing and then no heat is supplied, so no energy is being supplied to the system. Okay, so this was a graph of these different types of processes in thermodynamics. Thank you.